Welcome to this FortiConverter workshop. My name is Michael Strickland from the product management team. In this session, we have the following goals and objectives. We're going to identify key capabilities of the FortiConverter and look at typical customers and the licensing requirements. We'll just run through the different stages of the conversion wizard so we understand the requirements at each stage. We're going to review, once the conversion has run, we're going to look at the tuning capabilities and how we can modify the conversion data set and edit the policies. So then we're going to look at importing the conversion output into a FortiGate. After that, we're going to migrate FortiGate devices, so from an older to a newer FortiGate device, using both the CLI and the API. Then we're going to look at migrations to FortiManager, which are typically for checkpoint provider 1. After that, we're going to look at how firewall policies and NAT rules are merged into a single FortiOS policy. We'll also look at supported IPsec configurations, and we'll also look at debugging application issues. Okay, so FortiConverter is a software application for companies migrating to the FortiGate firewall and consulting services companies offering firewall migration services. Whether it's a large enterprise with many firewalls to convert, or consulting services company, or even our own internal employees. So it translates complex firewall configurations into FortiOS and FortiManager from a wide range of firewall vendors and OS versions, which are documented in our user guides and release notes. It's a subscription-based offering, so you purchase an entitlement to the software for a period of time, and that gives you direct engineering support and regular updates, as well as private builds for support issues. So just a word on licensing. Limited license for a single host. It uses a system ID, which is linked to parameters of the host it's installed on, and that will generate a license key. So there's a SKU for a new subscription and then a SKU for a renewal. Okay, so this is effectively an unlimited license. You can run as many conversions as you want. So the majority, actually interestingly, the majority of the customers are internal customers, so sales engineers, professional service engineers also use this tool. And then externally, probably the other third of our customers, and these are typically carriers, MSSPs, consulting services companies, finance. The trial license allows you to do migration. So you can review the converted rule set, and you can make changes, and just to get a feel of how the product's working. But there's no output with the trial version, so there's no CLI, CSV, or API output. So the license key enables the output. If you are just dealing with a single conversion, you've just got a firewall to convert, the licensing is prohibitive just for a single conversion, but you can work with your local SE, or potentially maybe a partner has this and they can do this for you. As I say, the licensing is geared around companies, organizations managing lots of firewalls and doing many migrations. So just a few reminders, always make sure that you do check the supported firewalls and convertible objects listed in the user guide. That changes. We add vendors, we add new releases, and we can obviously add vendors based on support requests where possible. Always, prior to migration, optimize your configuration. So it's not an auditing tool. It's not going to optimize your rule sets like many security policy management products will do. It's really the mechanics of migrating from Juniper or Checkpoint to FortiOS. So just a reminder, as for tidying up your rule set, as applications move in an organization or are removed, hard-coded rules may still be in the configuration and no longer used. So use the tools available to see which rules are in use. Obviously, removing items that are no longer in use really just increases the chance of success, because it's really optimized on what you're doing today, not leaving old rules in there that might no longer be needed and may actually cause an issue with the conversion engine. So to get started, you just select the vendor tile that you want to work with, and then you step through the wizard. When you start the conversion, the first thing you're required to enter is the conversion options. So once you've chosen the vendor, you will then be required to choose the model, the output format, so FortiGate or FortiManager. Okay, so that's essentially the difference is it just pure FortiOS, or is it FortiOS written to be imported into a policy package or into an ADOM? The output OS version, so the current releases now support 5.2 and 5.4. FortiGate to FortiGate conversions support older releases. The common conversion options are highlighted here. So there's many conversion options. Again, refer to the user guide for complete details. But the common conversion options, we'll just run through here. Okay. So one of the ones that when you have separate firewall policies and NAT rules, you have a conversion option. Ignore firewall policies with all or any addresses when processing NAT rules. If you have all or any objects, they will match every NAT rule. When we're processing NAT rules, what we do is we take our firewall policies, and then with each policy we process the NAT rules and we calculate is it an exact match, is it an intersection? So for example, there would be some firewall traffic and some traffic that's NATed. By using this, we may either modify the original rule or we create additional rules. Okay. Now, obviously, if you have all or any addresses, it's going to match a lot of policies. So it's generally recommended to switch this off. If you do have all any objects in there, maybe you can look at these beforehand. Maybe configure those afterwards. But just be aware that they'll have a massive overhead on the actual NAT merge. Okay. Another one's fairly obvious is discard and reference firewall objects. So objects not linked in the source configuration can be left behind. So obviously when you import a firewall configuration, FortiOS tells you, which objects are in use. But you may end up importing old legacy default objects that are actually, we have a different value, name, whatever for the same thing on FortiOS. So generally, when you're going from a legacy unit, you probably don't want to move all those old objects across and only use the ones that are relevant to your rule set. Okay. So by selecting that, anything that's unlinked is not copied across, and you will see that in the output. Another interesting one is auto-generate policy interfaces. So some FortiOS is interface-based firewall. You can specify any, but generally people provide an interface pairing, so from port 1 to port 2, for example. And so many people migrating to FortiOS want to take advantage of that. So the auto-generate policy interfaces, basically, if we take a source firewall that doesn't use interfaces or partially that uses interfaces, in the case of Checkpoint and Cisco, we can actually use the routing information and we look at the addresses on the firewall policy to identify the corresponding interface for those networks from the routing information. Okay, so that's what this mechanism does. Also, Checkpoint and Cisco have extended options, so there'll be a More button within the Start options, and you'll see some further options. As I say, the more complex the conversion, the more settings there are available. So we see some of the main ones here are on this tab is the NAT intersection calculation. So we're going to look at more. We're going to look into this more later on. But what this means is, how is the NAT intersection done? Okay, so and it depends on the conversion, the vendor, what NAT types are available. But although the NAT types vary, the values you can choose are the same. So you can either switch off the NAT merge for that NAT type. Why would you do that? Well, it just allows you to run a quick conversion just to get a feel of what it's doing. Okay, obviously it's not going to include the NAT, so it's not a useful production configuration, but it does give you an overall feel. Are the objects being handled correctly? How are the VPN objects being handled? how many rules is this generating? Generally, it should be quite comparable. It's when the NAT merge comes on that we see many more rules generated. It's just useful to run a quick conversion, and the time difference is massive as well. If you NAT merge really takes a lot of time. So if you do a quick conversion, it'll be finished on a very large data set. It'll be finished very, very quickly in a few minutes tops. But once you do the NAT merge, it can run for several hours. Okay, it's a very big calculation it has to run through. So if you are doing the NAT merge, then you can choose to base it on the names or the values. So obviously the object names, the object values. So the obvious one you think of is the value. We're going to look at the address and base the calculation on that, which is okay, which is generally the sensible way of doing it. But there are scenarios when names might be better. For example, if you have supernetting addresses, so it's an address that refers to many networks, so it's not an any address, okay, but it's an address that could potentially match a lot of objects. So just like 10.0.0.0/8, for example, an object like that would match a lot of NAT rules and create a lot of additional policies. So you can switch off those objects. You can match on the name only. So where this becomes interesting is if you have a policy that uses a supernet address, okay, it's only going to look at the name of that address and match NAT rules that match that. So you don't have it then go off and match any NAT rule that uses an address that starts with a 10. Okay, so that can significantly reduce the number of rules generated. So it's a useful option that you may want to enable. Again, start with a quick conversion and then start to enable the NAT types. Identity NAT here relates to the NAT rules in Checkpoint that when you use a rule to identify the same source, same destination to exclude the NAT happening. So you say ignat, NAT everything from this subnet except when the destination is this subnet, for example. Okay, so generally in FortiOS we don't need those rules because we're interface based. So the routing already, we don't have to make those exceptions in NATing because the routing wouldn't really allow those flows. Okay, so generally we don't convert those policies. If you want those, you can enable this option here. Okay. So again, just talking about the merge option examples, this is one I gave earlier. So if you have, for example, a source object, here we use an address as 10.252.0.0.14. This address can potentially match hundreds of NAT hide rules. Okay, so we can have a source file that contains tens of firewall rules suddenly containing hundreds of thousands of policies. Okay, so that's what these depth options are for. Another option is to adjust table sizes. What this relates to is things like address groups and addresses per group, which is probably one of the main ones. So it's how many are supported on my target device. So addresses per group is an interesting one. So for example, if and we'll see an example in a minute. If I only allow up to 300 addresses per group, and I have on my legacy firewall, I have an address group that has more than that, say 500, then it's going to create two address groups and index them and use them in the policy. That's how it deals with it. Okay, but you can actually change the defaults. So the defaults are based on something to work across the, apart from the very, very low end units across all firewalls. But if you're converting to a mid or high end unit, you might be able to change these and take advantage of these higher values. So just be aware of that. So you can see on your target device, if you don't know what these values are, there is a print table size command, and the user guide explains how to use this to see what the capabilities are of your target device. So the defaults work for most devices. In some cases, you may want to change them. So here we see an example, okay, and this is quite interesting because we actually see, this is the summary, and it's telling us here maximum address group membership, and it's telling us it detected up to 500 540 in one address group, but we're configured to support 300. So it's saying the maximum we're creating per address group is 300, so we've created two groups, okay, in this case, and linked them to the policy. So you can optimize the output by actually creating just a single group with the 540 policies in, but you need to tell the FortiConverter that it can do that by adjusting these values. So all the conversion options you used are saved in the conversion output. So this is just useful if you're reviewing your conversion afterwards. What settings did I use? If you want to rerun the same conversion, then you can just look at these and apply them. So you need to provide the source configurations. So based on the selected vendor, the algorithm will then specify the types of interface, the types of files to provide. Configurations must be in a text format, so plain text, XML, etc. Okay, binary files cannot be handled by the conversion engine. In addition, you can often supplement this information with routing information. So routing information detected in the configuration. So routes detected will be created as static routes. They'll be maintained, and they'll be used to facilitate the interface lookup when you do the auto lookup interface. So that's, as I said, when we're migrating from non-interface based firewalls, we'll want to run that and use the routing information. But obviously, that's just from static routes. So if you have dynamic routing, it's not going to see the routes that get learned from that. So this option, generally what we can do with these, we can also provide the routing file. Okay, so we can capture the routing table on the device as well. And that provides all the network reachability information. So we include that with the conversion, and that will actually be taken into the calculation. It will create static routes for those addresses too, and then you can edit those afterwards. And this allows us to do the full routing interface lookup with the full routing table. So context selection. So the FortiConverter is going to note if you've got vsys, lsys context configured, okay, and it's going to prompt you which ones you want to convert. So by default, all of them are enabled, but you could remove one, and also you could rename. So these maps. So the name of the virtual context becomes the name of the FortiGate VDOM. Okay, but this page allows you to rename those VDOMs and all references to those VDOMs within the configuration. So Checkpoint requires the management database files, which contain multiple firewalls and policy collections. So here we step through those, isolating the particular firewall we want to convert. So here you would choose the firewall you want to convert. Again, if you're using HA, you will actually see reported in here the HA cluster as well as the gateways. So just verify the device that you want to use. Additional routing information can be provided here for the firewall that you've selected. Also, you have an option to enable output to a non-root VDOM. So that just basically means if you're converting this and you want to import this into a FortiGate running VDOMs already and importing this as another VDOM, rather than putting this in root, actually structure this output in the config VDOM syntax and use the name of the VDOM that you provide here. So the next stage is physical interface mapping. All the physical interface is in the source firewall listed here, and then you define the mapping to the target device. Okay, you select the source interface either from a list of common FortiGate device interface names. You just type the name of the interface. And this provides the physical interface mapping. You can remove, if interfaces are presented from the source configuration and you know they're not used, you can delete them here. On the interfaces that you enter, the FortiGate interfaces, you can actually edit them. So you could create an aggregate interface here, which would then create that as a logical aggregate interface and use that throughout the remainder of the configuration steps. You can also just say an interface is unspecified. Okay, in that case, the the interface specific settings are ignored. The advantage of the unspecified is it's just basically a name-to-name mapping, okay? And what you would do here is that your target device is sort of default is running, either it's the config you want, either default or some partial configuration, and maybe it includes the interfaces you need. So, for example, if you wanted to reference a VLAN interface instead, you could, partly configure that on this. You say, I'm just going to reference the name of a physical interface and into VDAM link or whatever, and it's just a name-to-name mapping at that point. Okay, it's up to you how you do it. Or you can just do the physical interface mapping here and then go and do those changes later in the policy tuning. So once you get to the policy tuning, you can map anything back. So you can change physical to VLAN or VLAN to physical and so forth. As I say, you just either treat this as a physical interface mapping, or you can just type the names of the target interfaces on the device that you've partially configured. Okay, it is essentially a name-to-name mapping here. So the next stage is the VLAN and loopback interfaces. This is just an information screen. It's just going to show you based on your earlier mapping. So I've adjusted the physical interface. So the associated interface has now changed. I'm going to see the new interface has been, the new name, the new associated interface listed here. If you want to change these values, you can't do it here, but you can change that in the tuning. Okay, so here we see in the policy tuning how to, we select network objects and we can modify the interface type. So routing information. So routing information is recovered from the configuration, and optionally you can provide additional routes taken from the routing table which will be passed. So all this will be listed here for VDOM, and you can also edit, delete, add, modify this routing information here. So this is not just creating routes for your target device, it's also when you're using the auto interface lookup, these are the routes that are used to make those interface lookup decisions. Okay, so this is important to verify that these routes are correct. So when the conversion has run, you're going from the source config to a vendor specific data set. Okay, and this data set will then be used to create the FortiOS output. Okay, so it goes from a vendor specific data set into a Fortinet data set, which then becomes the output. And the tuning page allows us to modify that. So the tuning page actually shows us all the objects and the policies that are going to be created. Okay, and it allows us to change those. Okay, so here we see the conversion summary. So on this page we can go to the output, the tuning, go to report. So this just tells us information about the conversion, files used, how long it took to run, the output format, and so forth. You then have a summary of detected and created objects. This is just a quick snapshot. Say, okay, are there any major differences? Probably want to investigate those just to see what they are. It just gives me a general indication of how the conversion was handled. And then I see messages and warnings, and this tells me if any objects whether unsupported or weren't converted because they were a duplicate and so forth. So or removed because they were unreferenced, for example. So this it's important to look here because a lot of issues are caught here, and this often gets overlooked. So when you select Go to Tuning, you enter the new data set that's being constructed, and this will be used to produce the eventual configuration. Here we see the policies, the objects, the interfaces, everything that makes that rule set. And any changes we make here are immediately changed to the data set. So when we come in to tuning, it prompts us, do we want to back up? Okay. What it's saying is, do we want to back up the data set, create a copy of it? Because anything we change now is going to modify immediately the data set. So what it's saying is, do you want to create a backup of your post-conversion data set? The same when you exit this, when you go back to the results, it's going to ask you again, do you want to now create a backup of your modified data set? Now, you don't need to, or the the changes you made are applied, but it's just saying if you want a separate backup. Okay, so it's just prompting you. Okay. Also from here, you can export to CSV, which we'll look at later. We have also the NAT merge tab and the conversion log, so we can actually see the NAT merge review tells us how the rules were created, so the source, firewall, and NAT policies, and also we have the conversion logs of all the objects handled. Okay, we can also back up and save this as a tuning snapshot, which we can then restore at any point by selecting our vendor and loading a tuning backup. Also, we can export to CSV format. So the CSV format is very handy because we can obviously open that in a spreadsheet, and this allows you to share. So it's just the policies that are exported here, and this allows you to share this with a team, so you can email it to a team for wider distribution. You can get feedback from different groups, and this is interesting because obviously in a migration project there are potentially old policies that can be removed, and this really brings it to people's attention. When you send them a spreadsheet of the new rule set, they can go through, they'll see objects and maybe say, okay, yeah, no, these are now been taken out of commission, and so we can remove those. So it's just an opportunity to get many people to involve and review it. So that's the export, but what you can do with the import is that if you have decided we're going to make some changes, the import allows you to do a bulk import, bulk changes, so you can import many changes, so deleting several policies, and then even making some changes to the referencing objects, and then when importing, the original policies are replaced and the relationship between the policies and the objects is rebuilt. The report provides us an HTML format of the conversion, showing us converted, unconverted objects. It provides it in a formatted view. We see all the objects created. If we click on one of those, we can see in the frame on the right, we can see the actual CLI for that object. And then finally, we have the output. So this is the actual CLI commands that are sent to the FortiGate device. So the output is split into multiple files, so there's an order you need to import these. So obviously you need to import the interface configurations and the firewall addresses before you start importing the policies. Also these files, so by being split up, it means we can just deal with one set of objects at a time, make sure they import and then move on to the next one. And the firewall policies, for example, firewall addresses, which are potentially very big files and have many objects, they may be split into multiple index files. So you can, for example, firewall address 1, address 2, and so forth. So you import them in order. And the reason they're split into multiple files is just simple for the bulk CLI import. Config all contains the entire configuration, so that's just for convenience. Okay, generally importing that isn't too practical because there's just so many objects, and the bulk CLI probably won't handle it. So it's generally broken up into objects, which is just easier to manage and to import. So now we're going to look at importing the converter output into FortiGate. So the default output is bulk CLI. And it's structured into the CLI branches, and then we have to import that. So obviously we have to import that in order. So we have to import system settings first, then firewall objects, and then firewall policies. Obviously we need to import addresses before address groups, and so on. Also, you need to scan through the output beforehand. Just look for any lines that have been commented out, so starting with a hash or a pound sign. So these lines will be comments inserted by FortiConverter, and it's not necessarily an error, it's prompting you that something needs your attention. Okay. Often if this comment is inserted, it is an error, but you should check. So it may be, for example, take an example of a VIP that you actually use the same external IP address twice, okay? And it's prompting you just a warning there. So you just have to validate these, okay? So with the converter output, the recommended method of importing the output is using the bulk CLI capability or configuration scripts, as it's now known in 5.4. So in a system advanced, we select configuration scripts and we can upload the file. But this will just say success or fail. It doesn't tell us why it failed, okay? So if we do get a fail message, we need to switch on the debugging shown here to see that. However, it's good practice just to have the debugging on anyway when you're doing this. Okay, so we're going to go through that. So the CLI debugging facilitates the troubleshooting. So we're going to increase the debugging level. The debugging level is by default 3, okay, and we're going to increase that to level 8. If you want to, when you finish with this and you want to set it back to default settings, just enter diag debug reset. Okay, so these commands here, diag debug enable if I'm connecting via SSH, diag debug CLI 8 increases the debugging level, and then diag debug info just to see what my settings are. So I'm going to do a very simple example. We have this short, very small config with addresses and address group, and there's an object missing. Okay, we're missing an address from the address group, so it's, we have this deliberate error. Okay, so test3 is not defined. So when I load that, I see status failure, but I don't see why it failed. Okay, so I know it's failed, so I have to go to the CLI debug. So here I now see the error codes. So 0 indicates it's okay, so that's a normal return code. Then I see -3, so that's actually saying that's an error code, and in this case the object's missing or it's not defined. And then subsequently I have a return code 1 saying it failed. Okay, so the firewall address group has failed. The firewall addresses have been created, so it's important to note that when we're doing this method, it's not sent as a transaction. The objects are created, and anything that fails, well, it will be indicated here. So the addresses were created. It's the address group that's not there. So to correct this, obviously this is a very simple fix. I'm going to add the missing object. Now I don't need to. I can just edit in this case, the firewall address file and add that. And I can replay the same script and just, for the objects that exist already, it's just going to overwrite them with the same settings, and it's going to add the new or the missing objects. So now when I run that again, I see that when we get to the address group, we now get the 0 return code saying everything's okay, and we see in the GUI that the status is success. So now I'm just going to show you a quick demonstration of this, importing a bulk CLI file and observing the debug from an SSH connection. So next we're going to look at FortiGate migration. So this is from a legacy FortiGate device to a new FortiGate device. So for example, a C to E series migration. So first of all, when you're migrating, the first thing is that your new FortiGate will have different physical interface layout and capabilities. Also, the source and target FortiGates won't support the same OS version, so you can't update your old firewall up to the newest version and then copy the config across. You need a way of getting that config from the source firewall, applying fixing it for the upgrades, and then installing it on the target device. One option would be to use a third unit that supports both the source and target releases. So you could just do the interface mapping, upgrade it, then back it up and do the interface mapping again. Or you can use the FortiConverter to do this. The FortiGate migration runs in the trial mode. You don't need a license for this conversion. The FortiConverter helps build your new configuration. So it needs two things. It requires the running configuration of your source FortiGate and the default configuration of your target FortiGate. We say default configuration, but it could be partially configured. For example, you may enable VDOMs if you want VDOM support. You may also want to pre-configure it with some of the interfaces you want to use, such as VLANs, aggregate interfaces, and so forth. You use the option here, create a restorable config. So, as you're aware, the default output is bulk CLI commands. If you enable this option, it actually builds a config file, but it's an unusual config file because it takes the default configuration that you supply it with the header information, and then it appends to that, at the end of it, the actual migrated object. So the configuration is detected in the source, it modifies, it converts that, and then it appends to that any unconverted objects, so configurations that were made, but we haven't got a rule for in the conversion engine. In that case, it will be handled by the config error log. That will just prompt us. It will just prompt us there's an issue. So it's basically three phases. The original one, so we preserve the headers, the default settings, the merged objects, and any other object we couldn't convert, and that will be picked up with the config error log. Okay. And that file can actually be restored via the restore procedure, so we can restore that to the device. Obviously, once that's done, we want to get a proper backup. Obviously, we discard the one FortiConverter produced because that's got 3 sections to it, and we get the actual backup. We do an initial backup from our new FortiGate device. So here I see, if I look at the file, so when I create when I do a conversion with the restorable config option, I see the headers of the target device. So they're correct for the device. If you intend to use VDOMs on the target device, you need to enable that first. So that your default configuration from the target device has the VDOM admin enabled. Then if you scroll down, if you just search hash migrated, you find conversion from FortiConverter, which is appended to this. So it's going to actually overwrite some of those system settings. So for example, you're going to see config system interface, config firewall address twice. So you're going to see it once in the default and then again in the migrated objects. Obviously, it's the migrated objects that are the ones that are processed afterwards, and they're the values that are kept. So it's the migrated settings that are actually handled second. So we have the initial settings, and then the new settings are just reapplied on that. So we have the defaults, and then we apply the conversion. Using this approach, you will see some errors on the config error log. Now, some will be just differences that cannot be handled between the two devices. Others will be others may be an issue with the conversion logic, so we may have to make a change on the FortiConverter side. But you can still, using this debug information, you can troubleshoot this yourself and make the correction anyway, and then you can apply that to your other conversions. So the config error log is basically just showing us the bits that it couldn't pass. So in this case, we see a lot of DLP sensor errors, and this is actually a known issue. Here we were going from 4.3 to 5.4, and the changes are so significant. Even FortiOS doesn't keep the settings, okay? So here we just, they're not copied across. So when we, for example, in this case, we're referencing as a DLP sensor that doesn't exist, so we see this error for a non-existent object. Okay, entry not found. So here we see some common error code. You'll see several. So -651 input error, so the command is correct. -3, which we see here, entry not found. The previous option, we created a a config file that could be restored as opposed to imported as bulk CLI scripts. Okay. The other option is to use the API. FortiOS 5.4.1, 40 and above, FortiConverter supports migrations using the API. So this is interesting because it allows us, rather than having to provide that initial target device configuration, we can just connect and query the device via its API, and then we can also do the restore via the API. So one thing to note, the current version of FortiConverter, it only supports TLS version 1.0, so you need to enable this for the API connection to be successful, and then obviously you need to disable it afterwards. So here we see, again, same source configuration file, okay, but now we're connecting to the target device, okay. So via the target device's API, we specify IP address, username, password, and it's going to connect to that device, okay? And that's going to allow it to connect and retrieve the system information, okay? So the interface is available to actually download the configuration, to rebuild the configuration, the same process that we do to rebuild a new configuration and restore that. All that can be controlled from FortiConverter. Here now I'm mapping the interfaces again. I only have to keep the interfaces I'm interested in. I can delete interfaces that I don't have a mapping for. Might be the case that my target firewall has fewer interfaces than my source firewall. Okay, now this list of interfaces here, when I choose, so I've got my source interface and the FortiGate interface, the list is that I'm presented with comes from the FortiGate. It's being queried what interfaces are available. Okay, if for whatever reason an interface that you had there wasn't shown there, you can still type. It's still a name-to-name mapping, so you can still type the interface name if you wish. Okay, so the conversion runs and we'll see some summary information. Okay, for example, look at the messages and warnings tab because there we'll see any objects that weren't handled. So for example, we said earlier that when you look at the config error log, you'll see an error for the DLP sensor. But the messages and warnings tells us that this config is not supported. We see the setting for the DLP sensor there is not supported. So at least we know what to look out for, what to be aware of. So once the conversion is done, I can look at the output just to see what the conversion output looks. Then when I hit on restore, what it's going to do is, first of all, it's the same procedure as before. So it's going to recover the running default configuration, okay, and then it's going to build a new configuration by taking that default configuration and appending the migrated objects, okay. But just this time around, it's all remotely controlled from the FortiConverter via the API. And again, once that restores, I need to look at the config error log to see if any of the config commands couldn't be handled by FortiOS, and then obviously using the message there, the line number, I need to go back and identify what the issue was. So now we're going to have a second demo, this time looking at the FortiGate to FortiGate migrations using the API. So now we're going to look at migration to FortiManager, and the example we're using is for Provider 1. So Provider 1 was the original use case for using migrations to FortiManager. So here we're just migrating from one management platform to another. However, FortiManager is often used as an output format for regular firewall conversions. So this output, rather than being installed on a device, would be imported policy packages and objects in the in FortiManager's policy and objects database. Okay, so here we're going to select Provider 1 and output format FortiManager. So this is going to give me a format structure to use FortiManager's global ADOMS and device level ADOMS. Okay, so the source configuration requirements are different here. So I provide the multi-domain security management source files. So this defines policy packages and objects in the global ADOM, which can then be assigned to a device in an ADOM as header or footer policies. From those source files, in the next two steps, which I won't show here, I specify the MDS source server to use and the global policy collections we're going to convert. Okay. Once I've chosen the global policies and objects I want to convert, I'm then going to select the domain. So I've selected from the MDS source files the global objects. I'm now going to select the domains, which would be equivalent to ADOMS on FortiManager. So once I've chosen the global policies and objects I wanted to convert, I'm then going to select which domains to convert. Okay. After this, we'll then be prompted for which policy collections within those selected domains we want to convert to. So in this example we're going to do now, we're using FortiManager 5.2 with global policies and objects. So first of all, we must to import this output, we must enable ADOMS on FortiManager, and then we create an ADOM for each MDS domain to be migrated. Check when you create your ADOMS, including the global, that they're all set for the same FortiOS versions. Okay. Now, general recommendation is that you would import global objects and policies first, as these you would assign to policy packages in device ADOMS. Policies that you import may have a dependency on a global object. If we look at the output from Provider 1, we have a folder for global and then a folder per MDS domain. Each domain contains a folder FortiManager, and we have firewall objects and policy objects. So again, you always start with the firewall objects and then the policies. So again, we use the config split. Okay, so the different branches. So we have addresses, address groups, services, policy 6. Everything that is exported is to be run on the policy package or ADOM database. Okay, so this is the policy and objects for the ADOM database. These aren't device level settings, with the exception of the config system session helper file. Okay, this relates to certain services. For example, in Checkpoint have an application type, and in FortiOS equivalent, you would have a session helper that would, it would recognize a protocol and say, okay, well, this is FTP, so I'm going to expect this behavior, a control channel and separate data channels. The settings for those are included in this file. You need to enable scripts in FortiManager. Okay, so depending on the version, so you enable scripts in the system settings, and also you need to enable scripts for the global ADOM. So we're going to run through, it's very similar in importing scripts. So first of all, you would want to check the objects for any comments before you import them. Okay, so obviously you need to start with objects and then policies, making sure to import them in the order of dependencies, so addresses before address groups. So you choose import, select the file, and create a name for this script, okay? And then you choose what to run this script on. So is it on the ADOM database or is it on the device? Okay, so typically it's for FortiConverter migrations, it's always the ADOM database. When it's imported, you can check at this stage for the error messages. You'll see just for any sections commented out. Okay, once you're happy that's okay, you run the script. So you just right click and run and you select the target. So in the case of when you're importing objects into an ADOM, well, objects are global to an ADOM, whereas policy packages within the same ADOM refer to the same object. So actually you can select any, if you're importing objects, you can select any policy package, so the default will do. Okay, so you need to go through this for all the scripts in the global FMGR FW object folder. So here we've imported all the global addresses, address groups, services, and so forth. Okay, you may get an import error. Okay, so we're going to look in a later step. We'll look at troubleshooting these. Once we've imported the objects, we can then import the policies. So then we go to the global FMGR policy folder, okay, and then we have, and then there will be a folder per policy package, okay. So you will have the output split into different policy types. So policy, policy 6, policy 4.6, and again, if it's a very big file, it may be indexed, so you might have multiple files in there. So again, so you go through all those files and import them. And again, we'll look at troubleshooting import errors later. Once you've imported your objects and your policies, and that's imported okay, there's no errors, then you have these objects in the global database. Now you need to assign those to ADOMS. Okay, so we do just using the assignment tab. So we select the ADOM to assign this to, and whether to specify all policy packages or certain ones. So this becomes an assignment rule, and then when we assign, we push the config to the device ADOM. So when you've assigned your global policies, go to your ADOM and look at your policy package and look at your header and footer policies. Okay, so you've got your local policies, and then you'll have your header and footer policies. These have been assigned from the global ADOM. So just check that that assignment has worked correctly. So once you've imported the global ADOM, and then you've also assigned global policies and objects to device ADOMs, you can then start importing the policy packages for the ADOM. So, you repeat the import procedures. So for each domain name, FMG, firewall object first, and then policy, and import those. All scripts run on the policy package ADOM database, so basically on policy and objects database, with the exception of the session helper, which is run at the device manager. Alternatively, these are just changes you could make directly on the firewall. Okay, it's just telling you that these session helpers need to be set. Also, session helpers are configured by default anyway on FortiOS. We would need to create a new one, for example, if we're running FTP on a non-standard port. So for example, 2121, then we'd need to create a new session helper. Again, once imported, check for any error messages flagged with a comment. Again, then you need to look at these before doing the import to see if they're going to be an issue or not, and if they need correcting. So now we'll need to create policy packages, because before we were just importing, so when we're just importing objects, we can apply it to any policy package because it's global to the ADOM. But now we need to create policy packages. Okay, so we create a policy package for each policy collection folder. And to do this, you can just right-click on the default one in the GUI and create a new package. unselect the option to clone because we're going to import everything, and then when you come to execute the script, just select, when you're importing the policies, select the correct policy package to import to. It won't be the default one in this case. So, what to do if there's an execution error? So we've seen several examples of where we're importing scripts. So it's very similar with the FortiGate when we're using the bulk CLI import. We're looking at, we've got CLI output and we're going to get an error. However, it's a very different behavior to the FortiGate because the FortiGate creates the objects up to the point of failure, whereas with FortiManager, because we're making changes to a database, this is run as a transaction. So if something fails, it all fails. So we will see an error message. Okay, this is we'll get a pop-up telling us the status, the progress of an assignment or a script run. And if there's an error, we can see the message there, or we can just return to the task monitor because that's kept in the history. So from there, we can see the error message. Okay. So here I see the name of an object, edit, and then stopped, and then failed to commit to DB. So if I go back to that object reference, here I see it was an incomplete command. So for some reason, a value was missing. Okay, so it could have come from something in the source config, it could have been an error in the FortiConverter conversion engine, but here I see now that what the issue is. So in this case, I can manually correct that and then rerun the script. Again, same as FortiOS, we split the when there are many objects, we split the commands into several smaller index files. Obviously, when we're importing a FortiManager database, potentially a lot of objects in there. So here we see 15 address object files. Okay. So we split the files because it's simpler to troubleshoot, and also because when running the scripts in FortiManager, they only accept so many commands. Okay, so we just keep them shorter, so we're well under that limit. Okay, if you run a script and it doesn't work, you could try splitting it again into two subparts and running it again to try and isolate the error. Okay, maybe the first half runs okay and the second half is an issue. This approach just helps troubleshooting. One thing to be aware of is when you have nested groups. For example, when you're importing groups, you have nested groups. You may have a referencing object that's not yet been created. Now, generally FortiConverter spots nested groups and actually puts those at the very last file, but again, just something to be aware of. So you can delete a script from the GUI, but it doesn't actually remove the files. If you want to remove the files, you have to do this from the CLI. So it's execute FM scripts, and you can see what there is, and there's commands to run them, delete them, and so forth. However, generally, you probably want to, if you keep the bad script, then you've got some history. You've got the error message. You can go back and look at, you can go back and look at it and look at the error message. So you have a history. But if you just want to keep clean scripts, then you can delete it by using this command. An alternative to importing into FortiManager is to import to the FortiGate first and then import into FortiManager. This has the added benefit of maintaining your interfaces. With the current release of FortiConverter, when going from provider 1 to FortiManager, we don't have the source destination interfaces in the policies. So the policies in FortiManager are from source network to destination network, and the interfaces are any to any. Another thing you can do once we've imported a policy package into FortiManager is to make use of the consistency check. So FortiConverter is just concerned of the mechanics of moving from one vendor's firewall operating system, management system to Fortinet. It doesn't do any significant auditing. Now, FortiManager has a capability to look at a consistency check, so it can look for duplicate objects, policy shadowing, and so forth. So you can run that when you've imported your policy packages. You can run that consistency check. So next we look at NAT merge. So migrating to FortiOS is complex because FortiOS combines firewall policies and NAT rules within a single policy, whereas other vendors may keep these separate. So one of the biggest parts of FortiConverter is doing this NAT merge, and there are many conversion options related to the NAT merge. Also, you'll often hear that, but they ran a customer ran a conversion, and then they had many more rules in the output. Well, aside from being an interface-based firewall, which could actually generate more firewall rules anyway, NAT merge can often account for many of these. So this is why we showed some of the options earlier on to control the NAT merge depth. So here we're going to look at some specific use cases of how the NAT merge works. So we leverage the policy IDs to identify some of the NAT rules that have been generated. So just for now, we'll just say that the default offset is 10,000. So basically, checkpoint policy 1 would be ID 10,001. Okay. And then we use this, so we take the firewall rule maps to this offset, and then we generate additional indexes off this offset to identify additional NAT rules that have been created. Okay, so we're going to look now at a few examples, but let's just first explain the merge types. So there's an exact match, okay, and this happens a lot. Okay, so basically the firewall the address in the firewall policy exactly matches the NAT rule. So we just change the rule. We are just applying NAT to it. So the policy ID is still a 5-digit policy ID. So for example, 10,001. Okay. The other type of match is an intersect match. So for example, a firewall policy contains a NAT address. Okay. So this, but there are other addresses that aren't NATed, and this also appears frequently. Another potential one is that the NAT rule address contains a firewall policy address. So usually it's the other way around. The firewall policy matches more, and the NAT rule is quite specific. But it could be the other way around, that it's the NAT rule is containing firewall policy addresses. So it's a NAT rule that's matching maybe multiple firewall policies. So when we have an intersect match, okay, it doesn't wholly match it. So some of the traffic wouldn't be NATed, but some is. Then the policy ID format changes. So we prepend the number. So for example, if we were working on, let's say, checkpoint policy 1, and then we had an intersect match, the original firewall policy would still be, so the new ID was 10,001, so that ID would stay the same, that policy would still be there, but then we'd break out a separate rule for the NAT rule, okay, and we'd prepend that with a counter, so 1, 2, and so forth. So in this case, it would be 11,001. Okay. In this case, we're saying this. We now have this initial letter that you see, the initial number that you see in red here, is an index, is a counter. So we're saying that for this policy ID, we're detecting this is an additional NAT rule that's been generated by combining the two. Another one is an all match, and that's basically where the NAT addresses matches the all address in a policy. So this appears frequently, but usually its matching is unintentional. Generally our NAT rules are going to be quite specific, so we don't really want to be matching all addresses. So we should disable the all matching. Okay, so we're looking specifically at exact and intersect match. Okay, so let's just go through some examples here. So the first one, we're going to look at an identity map NAT. Okay, so this is where we're saying this is a a rule not to NAT. So we're saying in this case, this address should not be translated. Now, generally for identity type rules, FortiOS is interface based, as I mentioned earlier. So issues of directionality are often handled already in the routing. So we don't need to create NAT exceptions typically to a NAT rule, because that type of NAT exception you're describing would not be allowed by the traffic flow anyway. Okay. Again, we have another couple of examples here, which we also ignore because the real and mapped addresses are the same. Okay, so generally, identity NAT, FortiConverter will ignore. So here we have an example of dynamic NAT with a NAT IP. Okay, so I see I'm given a dynamic rule. Okay, so here I see just a natting that I'm saying this is the outside address I use for this corresponding internal address. Here is the my policy. So I'm saying that for the inside address, I use this external IP. Okay, so I reference the IP pool. In this case, it's an exact match. Okay, I can see that the NAT rule and the policy match the same address, the same source address. So we just use the normal policy ID. Okay, this is an exact match. Okay. Another example is dynamic NAT with a mapped interface. So in this case, I have an internal address for the source, and the external address is just an interface. Okay, so in this case, port 2. Okay, so in a firewall policy, when I enable NAT and I don't specify an IP pool, then it just uses the egress interface for its NAT IP. So now I have an example for static NAT. Okay, so I've got a one-to-one mapping. So I have the static NAT role. Okay, so this is represented as a virtual IP. Okay, because that provides me a true one-to-one mapping. So the VIP doesn't have to be referenced, and this provides us a static one-to-one mapping. So I've defined the VIP, which gives me my external IP and my mapped IP, and this gives a one-to-one mapping, even the other way around, from going from internal to external, it preserves that mapping. Okay. And there's my firewall policy. So again, this is an exact match, okay, because I see the mapped IP and the source address are the same. So in this case, we just change the policy. We don't create additional policies. So this is an exact match, and the static source NAT is done with a VIP. Now here we have a static NAT matching the destination address. Okay. Similar object, so we see we've got the static rule, okay, and this time we have a policy. This time it's the destination address that matches the external IP. Okay, so it's an exact match, so we don't need to create additional policies. Then we have an intersect match. Okay, so this happens. This is a common type of rule. So first of all, I have a dynamic NAT rule. Okay, so I have an IP pool there. My dynamic NAT rule is saying that for this inside address, this is my outside address. Okay, I have the firewall policy. Okay, so the firewall policy is represented here. Now, if I apply that NAT rule doesn't exactly match. Okay, that NAT rule doesn't exactly match. The source addresses are slightly different. So I've got the NAT rule is for 10.1.20/24, and the firewall policy is 10.1.00/16. So there's an intersect. So I have the original policy without NAT, and then I calculate the intersection. Okay, so basically, I create a new policy. Okay, in this case, this policy references the pool which is used for the dynamic NAT rule. Okay, so and this gives me my exact match here. So the 10.1, this gives me my match here. The 10.1.2.0 /24 source address is used here, and that matches the NAT rule in the source config. So I have the original firewall policy plus the calculated NAT intersection, which just applies to the 10.0.1.2, and that maps it to the IP pool. Another example, and this is one we typically recommend you switch off by default, is the all match. Okay, so with the all match, we see a dynamic NAT rule. Okay, so in this case, I'm mapping this inside address to this outside address. Okay, so I create an IP pool for the outside address. This is my original firewall policy. Okay, but because the source is any, it matches all the NAT rules. So I have to create a policy for this. Okay, for that firewall policy, applying those NAT settings. So when this occurs, we can end up with many more NAT rules than we need. Okay, so generally when you first do your conversions, well, generally you recommend you to switch this off, and if you do have those types of rules appearing in your source config, it's good to take note of those before and either decide to change them, ignore them, and modify them afterwards, because they will have a big impact on the conversion. And also, again, in all these examples, notice how the intersect policy preserves the original policy ID and then prepends an index. So in this case, 1 for the first policy, 2 for the second, and so forth. So a capability we have in 5.4 is central NAT. So with this setting enabled, with central NAT enabled, the FortiGate uses we have a central SNAT table. It is there in previous releases, and that's just for source NAT. Okay, but in 5.4, the central NAT setting does two things. It uses the central source NAT table for all SAS source NAT mappings, so only NAT can be enabled in the firewall policy, and then the IP pool selection or not is done from this table. And also, all VIPs are now unlinked from the firewall policy, so the list of VIPs acts as a destination NAT table. Okay, and also remember that destination NAT is pre-routing, so the firewall policies should refer to the mapped IP. So here's an example with the central NAT option. So I see I've given this host address and hide IP. Okay, so I have the host 172 address hiding behind this 210 address, and I have an exact match firewall policy. Okay, so I see the same source address, the 172 host. So the hide address is converted to an IP pool, and in this case, a central NAT object is created referencing this pool. Okay, so here, if I look at the configuration here, I see the hide NAT IP. I see an entry in the central NAT table, okay, which gives us the source address and the pool to use, and then just the firewall policy with the action NAT, okay, and then the IP pool, sorry, the IP pool to use comes from a lookup in the central NAT table. Another example of central NAT using destination NAT. So now my 172 host has a static NAT to a 210 address and an exact match firewall policy. Okay, so a VIP and firewall policy objects are created. So now FortiOS doesn't require, with Central NAT, doesn't require the firewall policy to reference the VIP. Okay, so the resulting config here is closer to the original checkpoint firewall policy in that rule. Okay, so here we see the VIP created and a firewall address object. Okay, in this case, this firewall address object refers to the mapped IP. Okay, and then we see the firewall policy with no explicit NAT action. With checkpoint, we have identity NAT and Cisco PICs. We have NAT exemption. Okay, so we've talked about this already, where source and destination host and network address are the same. So here, if we look at an example, let's say, so we see that 10.110/24 has a hide IP, this 200 address. Okay, so and we have a firewall policy, okay, that actually says, so we see we've got a source address of 10.11.5 and a destination address which is one is 10.2.1 and one is 10.1.1. Okay, so NAT should be performed on the traffic from 10.1.15 to 10.2.1.10. NAT should not be performed on the 10.1.1 to the 10.1.1 network. Okay, so in this case 10.1.15 to 10.1.16. When you enable, so there are, for some conversions you can enable identity NAT, which basically generates a policy shielding the flow from the NAT policy. Okay, so these rules have two purposes. In checkpoint, we can use these to exclude special cases that don't require NAT. In PICs, we can use these to allow traffic that does not require NAT when the NAT control mode is enabled. So it's basically, we put this rule first, and you can see that we have the regular, now in this case the regular policy has NAT applied, and then the NAT policy, so that's, in this case it's the example is it's policy 1000, and then the rule that's been created from this NAT calculation is prepended with an index, in this case 1, so this is 11,000. This will be a rule with no NAT action between those addresses. So this this excludes the NAT action happening for this flow. So next we look at IPsec VPN support. So currently there's support for Cisco Checkpoint and Juniper conversions. Generally it converts to policy-based IPsec, but some route-based conversions are supported too. It really converts to what the source configuration is closest to. So this is an area that engineering are looking to improve on in a future release. So there'll be support, explicit support for route-based, and also additional vendor support too. Okay. So here we see a Cisco PICs AutoKey example. Okay, so we see from this configuration. So we see the crypto map settings creating the phase 1 objects, the access lists being created into phase 2 objects and selectors referencing those phase 1s. And then we see the firewall policy with action IPsec. So basically, we're really just reapplying that same the same flows allowed in the IPsec selectors. Okay, so we see, and also this is policy based. So we're referring, as opposed to referring to an IPsec interface as a destination interface or source interface, we're actually, the action is IPsec, and we refer to the phase 1. So now we look at application troubleshooting. So just a couple of slides looking at basic things you can do when an exception occurs. Okay, because obviously there's so much variation in the types of configuration that FortiConverter can be expected to deal with, and the engine may crash. So if that happens, okay, well, first of all, contact FortiConverter support so that we can correct the conversion engine if correction is required. But often it can be something that was strange in the source configuration. On top of that, it might be something that you don't even want anyway. So sometimes with a bit of troubleshooting, you can actually look at where it failed, and you look at it in the config and say, oh, well, I didn't need that anyway, so I can comment that bit out. Okay. Generally, when it can, it will display an error message to the GUI, and it will also write an error to its log file. Okay, so this may indicate the part of the configuration that caused the exception. So this does allow you to do some troubleshooting yourself. If you require a fix for this exception error, then you can contact FortiConverter support, as I said, but just so that you can get on with your work, you may just knowing how to work around this will allow you to get on with your conversions. So here we see an example of the log output. So this log shows the conversion steps, including the initialization, parsers, conversion, report. So you can see how it's stepping through and how far it gets. If you see some object reference error, this generally indicates to an internal error. So at that point, you would need to contact the support alias. Well, that concludes the FortiConverter workshop. I hope you found this useful. Please return to our channel for future updates to this presentation. Thank you.